Good morning everyone. My name is Professor Swapnil S. Sudke of SND COE and Research Center Evla of Department of Electrical Engineering. Today we will discuss the topic of the subject Advanced Microcontroller and Embedded System of Unit 1, that is Introduction. In this topic we discuss the various topics like program counter, then stack pointer in computer system in detail. First of all, we discuss the topic that is program counter. The program counter PC, commonly called the instruction pointer IP in Intel x86 and Infineon microprocessors, and sometimes called the instruction address register IAR. The instruction counter, or just part of the instruction sequencer, is a processor register that indicates where a computer is in its program sequence. A program counter is a register in the CPU that contains the address of the next instruction to be executed from memory. The example of the program counter is that, for example, when your computer is turned on, a signal places the decimal number F000 into the CPU. This action tells the computer to look at the first instruction on the motherboard's flash memory chip. Then, what is program counter in 8085 microcontroller? The program counter PC in 8085 microcontroller are used as by the name microprocessor. 8085 PC is a 16-bit register. It contains a memory address. Then this PC contains that very memory address from where the next instruction is to be fetched for execution. Suppose the PC contains R8000H, then it means that the 8085 desires to fetch the instruction byte at 8000H. Then how can the program counter be loaded with the program address? The program counter can be accessed, modified by jump and branch instructions. Therefore, the destination address can be loaded to the program counter via branch instructions. The program counter can also be loaded with the address using the data processing instructions. Then the next topic is that program counter and its use in computer. It is a 16-bit special function register in the 8085 microprocessor. It keeps track of the next memory address of the instruction that is to be executed once the execution of the current instruction is completed. In other words, it holds the address of the memory location of the next instruction when the current instruction is executed by the microprocessor. The program counter PC is a register holding the address of the instruction which needs to be executed next. Then it used to keep track of current execution point. This tracking is necessary for various reasons, and some of these reasons are: 1. While branching or looping, destination address is specified with respect to the current PC value. Then second point is that while branching to a function call, current PC value is pushed into the stack and retrieved back when returning from the function call. Then the third point is that PC value is stored when servicing an interrupt and restored back after execution of ISR. The program counter is a 16-bit register which holds the address of the next instruction to be executed. Program counter is required to wait. In this point, the 2 points are: first point is it speeds up the execution of a task. Then second point, the destination address where an answer is to be stored is with reference to the current address in PC. The program counter holds the address of either the first byte of the next instruction to be fetched for execution or the address of the next byte of instruction which has been completely fetched. In both the cases, it gets incremented automatically one by one as the instruction byte get fetched. Also, program register keeps the address of next instruction. Then the program counter or PC, also called the instruction pointer or instruction address register or just part of the instruction sequencer in some computers, is a processor register that indicates where the computer is in its instruction sequence. Depending on the details of the particular computer, the PC holds either the address of the instruction being executed or the address of the next instruction to be executed. In most processors, the instruction pointer is incremented automatically after fetching a program instruction, so that instructions are normally retrieved sequentially from memory with certain instructions such as branches, jumps and subroutine calls and returns, interrupting the sequence by placing a new value in the program counter. Such a jump instructions allow a new address to be chosen as the start of the next part of the flow of instructions from the memory. A subroutine return is then achieved by writing the saved value back into the program counter again. They allow new values to be loaded, that is written into the program counter register. A subroutine call is achieved simply by reading the old counter's contents of the program counter before they are overwritten by a new value and saving them somewhere in memory or in another register. Then the next topic in this introduction point is that stack pointer. What is stack or stack pointer? First, we discuss the definition of the stack or stack pointer used in the computer system. The definition is that the stack is a storage device used for storing information or data in a manner of LIFO, that is last in first out. Whenever we enter the data in the form of LIFO manner, the element that has to be deleted first is the last inserter element, so the last inserted element is taken out first. It is the memory unit within an address register called stack pointer SP. The stack pointer always indicates the top element in the stack, that means which location the data has to be inserted. Then in the stack pointer, another information is that a stack pointer is a small register that stores the address of the last program request in a stack. Then a stack is a specialized buffer which stores data from the top to down. As new requests come in, they push down the older ones. The most recently entered request always resides at the top of the stack, and the program always takes request from the top. A stack, also called a push-down stack, operates in a last-in, first-out sense. When a new data item is entered or pushed onto the top of a stack, the stack pointer increments to the next physical memory address and the new item is copied to that address. Then, when a data item is pulled or popped from the top of a stack, the item is copied from the address of the stack pointer and the stack pointer decrements to the next available item at the top of the stack. Then the stack pointer also having some types and applications. The next point is that types of stack pointer and its applications in the computer system. There are two types of stacks. They are register stack and the memory stack. First we discuss the topic of register stack. The register stack is also a memory device present in the memory unit, but it handles only a small amount of data. The stack depth is always limited in the register stack because the size of the register stacks is very small compared to the memory stack. Then push operation in register stack. We discuss this push operation step by step. Step 1. The stack pointer increments by 1. That is, SP is incremented to the SP plus 1. In step 2, enter the data into the stack. That is, M in bracket SP is incremented to the DR, where DR is the data register. Then in step 3, check whether the stack is full or not. If SP is 0, then full is equal to 1. Then in step 4, mark not empty. Empty is denoted by empty equal to 0. But the stack pointer's push operation mark the not empty in the step 4. Then pop operation in stack register stack. In this operation, we discuss this operation by the step-by-step manner. In step 1, read data from the stack, that is DR, it is given to the M in bracket SP. Then in step 2, decrement stack point. SP is decremented to the SP minus 1. Then in step 3, check whether the stack is empty or not. If SP is 0, then empty is equal to 1. In the pop operation of the register stack in the computer system. Then the second type of the stack pointer is that memory stack. In the memory stack, the stack depth is flexible. It occupies a large amount of memory data, whereas in the register stack only a finite number of memory words will be stored. That is, memory stack is bigger than the register stack in the computer system. Then push operation in memory stack. We discuss this push operation step by step manner. In step 1, SP is incremented to the SP plus 1. Then in step 2, M in bracket SP is converted into the DR. This is the push operation of the stack pointer in memory stack. Then pop operation in memory stack. We discuss this operation in step by step manner. In step 1, dr is converted into the m in bracket sp. Then in step 2, sp is decremented to the sp minus 1. This is the pop operation of the stack pointer in the memory stack. Thank you.